A lot of you out there are probably familiar with ES6, which is the most recent version of JavaScript. And today we actually have really good browser support, at least for the major desktop browsers, for ES6. So things are looking good, and the time is right to talk about the future of JavaScript. Now, this is the last time you're going to hear me talk about versions of JavaScript. What used to be titled ES6 is now called ES 2015. And going forward, we're going to be releasing a new version of JavaScript every single year. So ES 2015, 16, 17. Now, the reality is, these versions don't really matter. In fact, because what's basically going to happen is, at the end of every year, whatever features are ready and mature enough, we're going to put in the spec, and they're going to make it into the language. So what actually matters with regard to the maturity of future JavaScript features is this maturity stages. So in order for me to responsibly talk with you about future versions of things coming down the pipe in JavaScript, given that they're not really done yet, given that they're not really baked, is to talk about maturity stages. So as features make their way through these maturity stages, we sort of say to the community, hey, these features are getting more and more mature, and they're getting more and more baked, and by the end of the year, whatever has made it to stage 4 makes it into the language spec and gets shipped. Now, the reason why versions don't really matter so much from the perspective of you, JavaScript developers, is that you can start using some of the features I'm going to be talking to you about today just by using Babel, for example, which does compilation from new JavaScript features in future versions to the existing versions of JavaScript supported by your browsers. So some of the features I'm going to be talking to you today, you can actually go away and use right away by using something like Babel. And as you can see, Babel actually has this little piece here where it supports multiple stages. So you can just say, hey, look, I want to use this stage 4 feature or this stage 3 feature. And you, as developers, are accepting the risk that if you use a stage 4 or stage 3 feature, it might change by the time it actually makes it into the standard. So later, the version, the more mature it is and the more likely it is to not change. Now today I'm going to be talking to you about a very specific question that is very important to me as a developer. I think a lot of JavaScript, people on the JavaScript committee stay up at night thinking about it, and that's how we can make asynchronous programming easier for you. Now, obviously, JavaScript is a single-threaded programming language, right? And we do a lot of UI programming in JavaScript. And in order to make sure that our UIs are responsive, we need to make sure that we write asynchronous code, right? Because if we write code that's synchronous and synchronously makes a network request, it blocks, and then our applications are not responsive to users. So starting in ES 2015, ES6, now titled ES 2015, we introduced this notion of promises to make asynchronous programming easier for you as developers. So promises are very simple. Promises are an object that represents a value that you'll eventually get asynchronously. And to consume them, you simply call the then method, and you pass 2 callbacks. One callback, the first callback, gets called if the promise succeeds with a value, and the second callback gets called instead if the promise errors, and then you get that error. So promises have a very simple API. And in ES5, you could take your functions that were synchronous and rewrite them asynchronously using promises. So here we see we have 2 sequential operations. One to get the symbol for a particular stock, and then once we've got the symbol for that stock, we make a follow-up request to get the price. Now, if we were doing this synchronously, things would block, so we don't want to do it synchronously. We instead, in the new version, in ES6, we have these functions return promises, and then we chain these sequential operations using then. So that's great if all you're doing is do this, then do that, then do that. But some functions, well, they're a little more complicated than that. So here's an example of a function that's a little more complicated. What if we might try one service to get the price for a stock, but then if that fails, we want to try another service, and we want to retry it multiple times. This particular function is a little bit more complicated than the one we saw before, and it's not immediately obvious. It's possible, but it's not immediately obvious how we would take it, and we would convert it over to use promises, right? So we're not entirely clear how that would work with promises. It would take some thinking, probably some recursion in there. So what we on the JavaScript committee have been asking ourselves is, look, why does synchronous programming and asynchronous programming have to look so different, right? I mean, there's no difference if a function returns a value or it delivers it to you in a callback. Why should you as a developer have to mangle your code just in order to change in which direction data is flowing? So that's why we have a very big feature coming in a future version of JavaScript called asynchronous functions. And these are stage 4 maturity level, which means they're very mature, and it's probably okay for you to go and start using them right away. So here we have that original function, getStockPrice, with its loop and its try-catch. And here is how you would write this same function asynchronously in an upcoming version of JavaScript. So here I'm introducing the async function concept in JavaScript. So notice that this code is nearly identical. The first thing you'll notice that's changed is we have this async keyword. And then we take all of these functions that now return promises, and all we have to do is put the await keyword in front of them. Now what happens is that although this code looks synchronous, at runtime, JavaScript is going to suspend the execution of this function until this promise resolves, and then resume at that point. What that means is that we don't have to worry about callbacks, and then notice that this function now has no callbacks whatsoever, and JavaScript worries about executing our code sequentially after the async function resolves. So that means we get to use all of the control flow constructs that we know and love, while loops, try-catch loops, inside of asynchronous functions, and we don't have to think very hard about how to turn our code inside out. So what that means is coming up in a future version of JavaScript, I think the big story for future versions of JavaScript is symmetrical support for synchronous and asynchronous programming. And that's a beautiful thing. So that's great. And it's great that we can do all the same things with async functions as we can do with regular synchronous functions. But you know what? We have an additional concern when we're worrying about asynchronous functions, and that's cancellation. Asynchronous functions, unlike synchronous functions, tend to run for long periods of time. And for those of you developing user interfaces, we know that sometimes users are fickle, right? They open up a form, and then they see a loading bar, and they get bored, and they hit the stop button. And if they decide to cancel the operation, we want to just stop doing anything, like whether it's make future asynchronous requests. We don't want to do that anymore, and we want to be able to cancel and stop, just like the user has told us they want to do. So starting in a future version of JavaScript, we're going to have a new notion called cancellation tokens. A cancel token is actually a very simple concept. It's really easy to understand. So you can create a cancel token using this method, cancelToken.source. And it actually hands you back a pair of two things. One is the actual cancellation token, but then the other is a cancel function. So let's pass this cancellation token to our asynchronous function, the one that we just saw, getStockPrice. So as we see, we just pass it as another parameter to the function. Now, if later on, while getStockPrice is doing its work, right, making a request to resolve the stock name to a symbol, then making a follow-up request to get the price, if we decide, you know what, I don't want to do that anymore, and we cancel, we just invoke the cancel function. And what that does is it causes the token to cancel, and then our getStockPrice function, whenever it finishes some asynchronous operation, before going forward, it's going to check that cancellation token. And if it sees that the cancellation token is canceled, it's just going to throw. And because it's throwing, it's never actually going to invoke our callback here, and it's effectively going to cancel. And that's how cancellation tokens work. So now let's see what this is like for the person actually writing the getStockPrice function, because they have to accept this cancellation token. So let's take a look at what getStockPrice now looks like. So here's the async function we saw earlier using the new async keyword. And here's what it's going to look like to write an asynchronous function that supports cancellation. So as you can see, we accept a cancellation token, and then after every await statement, we just go cancel token, throw if requested. In other words, if somebody called that cancel function that we saw earlier, this is going to throw at this point right here, and effectively that promises the rest of this code. Notice that getSymbolPrice will never get executed. And therefore, we save a whole network request that we didn't need to make because they want to cancel that function now. So that's a lot of boilerplate, as you can see, right? If every single time we have to write await, we have to write cancelToken.throw if requested, it can add up. It's a little bit of extra boilerplate. I think most of us wouldn't want to write that boilerplate. Part of the promise of asynchronous functions is that you don't have to write much more code than if you were writing synchronous functions. So how do we accomplish that? Well, we add a special contextual keyword called await.cancelToken. And this effectively replaces the code that you saw earlier. So these two pieces of code are actually equivalent. And so now, with that done, we can see that we can actually support cancellation in our asynchronous functions by adding only one extra line of code. So hopefully that's clear to you. Cancellation tokens are pretty simple, right? They're just a shared object that you pass around between your asynchronous functions, and if you cancel one, it's the responsibility of that asynchronous function to throw and stop executing. So asynchronous functions, I hope a lot of you are excited about it because they're pretty great, right? For those of us writing a lot of async code, and probably a lot of us are using promises already. By the way, can I see a quick show of hands? Who's using promises out there? A lot of people, right? So this is pretty powerful syntax that you can just use out of the gate. Now that's great, but there's also other types of functions in JavaScript. Some of these other types of functions were introduced as well in ES6 or ES 2015. One of those is the generator function. Now just a quick show of hands, I'm curious, how many people use generator functions? Or maybe indirectly some of you use them in libraries, right? So fewer hands, but it's a very powerful type of function. So a generator function, basically it's a function that returns multiple values. So a generator function can return multiple values, and when it's finished, it'll just tell you, hey, I'm done. So here's an example of a generator function in ES 2015. So in the old version of JavaScript, if you wanted to return multiple numbers, you'd probably just create an array of numbers and return it. So notice here, this is a little bit different. We see this yield keyword, and this yield keyword looks a little bit like a return, and that's a good mental model for thinking about how yield works. It's sort of like a function with multiple return statements. And what it does is it allows you to return multiple numbers, but instead of collecting them all up in an array and then returning them, you can return them progressively on demand as the consumer requests them. And that turns out to be a pretty powerful thing. So here's an example of how you use a generator function. So the first thing you do when you call a generator function, you actually get out this object called an iterator. And I think some of you are probably familiar with the concept of iteration. It's been around in computer science for a long, long time, 20 years, possibly longer. So you get an iterator, and then you call next, and then you get back this pair of values. One is the value the next number that you requested, and the other is a Boolean saying whether or not there's any more data. And so it turns out, yes, we have more data, so I'm going to call next again. And once again, we get another double, a little pair that says, yes, here's your number, and yes, we do have more data. So we call next again, until finally, we get a pair of the value, and then the done property is now true. So we know we're done. And that's how a generator function works. It allows the consumer to pull values out progressively of a function, and effectively lazily evaluates that function. So under the hood, for those of you who are curious about how yield works, one way of sort of figuring out, intuiting how yield works, is to imagine how you would write that iterator yourself if you had to. Well, you'd probably have to set up a state machine. So as you can see here, the first thing is this little example, this Fibonacci sequence, which is, of course, the ubiquitous programming example. We return a iterator. So you can see here, that's that outer object with the next method. And then if you keep calling it, each time you call it, this function checks what state it's in. So it effectively figures out every possible state that the function can be in, and then it just keeps moving through those states. So every single time you call next, it moves through the next state, and then it returns one of these pairs. So that's all it's doing. It's building a state machine. But iterators are really powerful because you don't have to build that state machine. You just write your code top to bottom. It's a little like async functions because you just write your code top to bottom as if that code's executing, and every single time the yield keyword comes up, the program might suspend, but then it'll resume from that yield point the next time you call next. So if we were to sort of like get a mental picture for how iteration works, what you do is you have a consumer and a producer. The consumer requests the iterator and then begins sort of pulling values out. And so we get 42, we pull out 39, and finally, we make our last request, we pull out that, and we get a pair back that says, okay, 19 and done. And that's how we know we're never supposed to call next again. So generator functions are great, but they have to produce values synchronously. And that doesn't make them very useful for some of our asynchronous streams that we have to deal with. So what are some examples of asynchronous streams of data that we have to deal with in the browser? Well, I can think of one that probably a lot of us have had to work with, which is WebSockets. Now, one of the reasons I can't use generator functions for WebSockets is because, well, when you get a value from a WebSocket, it's asynchronous, right? It calls you. And when you call next on a generator, it blocks until it delivers you that value. And so it's kind of unfortunate that we have this nice function in JavaScript for requesting values, streams of values, but we can't use it for WebSockets. So what's the solution? So what if we want to create an asynchronous stream of values? Starting in a future version of JavaScript, we are going to have the asynchronous equivalent of generator functions. And this is going to allow you to do things like work with streams, I/O streams of data like WebSockets in a much more elegant and fluent way. So here's an example of how we can consume iterators. So earlier I showed calling next, calling next. Well, thankfully, in ES 2015, we have a nice syntax for that. It's like a little for loop. And you'll see that we have a similar syntax for consuming asynchronous iterators soon. But here's how the producer looks. So if I want to create a generator function, right, and I want to read data from a file, now I can actually implement this in Node today, because Node actually supports synchronous I/O. I don't recommend you do that, because if you use synchronous I/O in your web server, you're not going to be able to serve other multiple concurrent requests while you're reading data from a file. So while this is possible, you probably shouldn't do it, right? So here's what it's going to look like to do the asynchronous equivalent of this in a future version of JavaScript. So I'll do that again, just in case anybody missed it. Right? Not too shabby, right? So all we did, once again, we added the async keyword, and we just go await in front of any asynchronous operation. So in Node, you could do something like this in the future to write code that consumes data from files, and it's not going to block. Now, that's great for the producer. Well, hold on, I'll just go through this little consumption set. So if we want to consume this, just like the previous example, it's pretty much the same. We request an asynchronous iterator, and then we call next. But now notice, when we call asynchronous iterator.next, we're actually, instead of getting back a pair of the value and a Boolean indicating whether we're done, we're going to get it back a promise of a pair of a value and a Boolean indicating we're done. So I just call then, and I log the result. I call next again because I'm not done. And we see that the code on the left-hand side resumes from where we left off. And finally, I keep calling it until I get my final value. So just an iterator of promises, of pairs, is kind of the right way to think about an asynchronous iterator. So once again, we'll visualize this process with an asynchronous iterator. We've got a consumer, we've got a producer. The consumer requests an asynchronous iterator from the producer, and it requests a value, but this time the producer gives a promise to the consumer. And then the consumer resolves that promise and gets back a value. And we keep going like that. Now notice at the end, we just go ahead and we return this last value, but it always gets wrapped in a promise. So even though we're just returning 19, it's still going to get wrapped in a promise, so the consumer doesn't have to worry about getting a value or a promise. And that's similar to the way that the promise then method works, right? If you remember, from your function inside of then, you can either return another promise or a raw value, and it all gets wrapped up into a promise. So we see asynchronous iterator works the same way. And so we're finally done. We stop. So we saw what it's like to produce an asynchronous stream, but what about consuming an asynchronous stream? How do we consume it? Well, in ES6, we added this nice sugary syntax, for of. So we don't have to write that next, 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 and that while loop, right? So it's a lot nicer to consume data this way from a stream. Starting in a future version of JavaScript, we are going to see this. So as you can see, we've got for await, right? And everything else is pretty much the same. Just sprinkle await through keywords throughout your function, and it pretty much just works. So you don't have to think very hard. Once again, the focus is on symmetrical support for asynchronous and synchronous programming. So where are we going to use this? Well, pretty much this is a really appropriate type for any kind of push I/O, right? Whenever we've got I/O that's being asynchronously handled, one such case is obviously WebSockets, but another case could be Node streams. And it's quite possible in the future, both of these types could implement the asynchronous iterable contract, which means you can use for await on them inside of asynchronous functions. Make sense? So there are some streams that are not very patient. They will not wait for you to be ready and request another value from them. Now, perhaps the most notable example of such a stream in the browser is Event Target, the Event Target API, which I think a lot of us in the room know better as add event listener, remove event listener. The thing about DOM events is they don't particularly care whether we're ready for them or not. Whenever somebody moves that mouse or whenever the DOM loads, it's going to call our callback right away, and we have to react to those callbacks. So asynchronous iterator isn't really an appropriate API for that type of thing, right? Asynchronous iterator is for when the consumer's in control, right? When you want to decide when to pull the next value. So we need another type for these push streams. So here's an example of some push streams, DOM events, set interval, right, which calls a callback every few seconds, right? Set timeout's actually probably not as good an example. That's probably something better for a promise because it only calls you once. So the interesting thing about the web is that there's no standard observable interface. We have an iterable interface, which is now standard in the latest version of JavaScript, but we have no standard way of observing data. So you have a lot of different APIs which can push you and call callbacks, but there's no one interface to capture all of them in a consistent way. So here we have another proposal for an observable interface in the upcoming version of JavaScript, and that's currently at stage 1. So I'll tell you a little bit how it works, but I think you're going to start to recognize a pattern as we go through it. First of all, here's what the interface looks like. It's actually two interfaces. We have the observable interface, which accepts an observer, and an observer is really like a batch of 3 different callbacks. It can push you a value, it can push you an error, or it can push you a completion message. And the idea behind an observable is it's really to take the iterator contract that we showed you earlier and kind of flip it inside out, right? An iterator, as we saw earlier, you can keep pulling values out until finally you get that little pair that says you're done, right? And another possibility is that when you call next on that iterator, just like when you execute any JavaScript function, it could throw. And so there's really 3 semantics that iterator supports, which is give me a value, tell me whether I'm done or not, and possibly throw an error. And so what we're doing on the committee is we're trying to take all the same semantics that you have in the iterator contract, and we're turning them inside out for the observer contract. And so instead of you calling next on an iterator, you provide the observable with an observer, and it calls next on that observer and pushes the data to you. So the difference is really about pulling data out, which you do with an iterator, or pushing data at you, which is what's done with an observer. So let's see what that looks like. So we actually have, as I said, these 2 interfaces that work together. So let's visualize it. So let's pick up where we left off with iteration. So we still have a consumer and we still have a producer. But now the producer is going to be the observable. And instead of a consumer requesting an iterator from the producer, it's going to provide an observer to the observable. It's going to provide an observer to that producer. So we pass in the observer, and then the producer actually pushes data at us by calling our callback. So it calls those 3 callbacks, observer.next pushes at 42, and then it'll just keep pushing. So in this case, notice the big difference here is the producer is in control, not the consumer. I don't decide when I get the next value. The producer decides when I get the next value. And that's how DOM events work, and that's how setInterval works, right? So we're trying to capture an interface, trying to pick one nice, consistent interface for handling this type of interaction. And so the equivalent of giving us a pair with that done::true on it is actually invoking our complete callback. So it's the same semantic. It's handled a little bit differently because it's more convenient to get a special callback for when we're done, but it's basically the same 3 underlying semantics. So one of the nice things about observable is that it actually is going to support the same mechanism of cancellation that the asynchronous functions we saw earlier are. So optionally, you can provide subscribe with a cancel token. Because let's say you subscribe up to an event, and you decide at some point you don't want to listen to that event anymore, right? Today you would call remove event listener, but the equivalent of that in the new world is you're just going to be able to take that cancellation token and then call cancel on that. You're going to cancel that cancellation token, and then the observable is going to check that cancellation token, and if it's canceled, it's going to unsubscribe for you. So no more add event listener or remove event listener. You're basically just going to be able to use the same cancellation token you're already using in your asynchronous functions and thread them right down to events. So as you can see, you can call subscribe and pass in this observer object. That's what's right here with the next, complete, and error functions, and then the optional cancellation token. So that's how the observer works. And if we were to go ahead and run this, we might get pushed three values in a row, and that last value is going to say done. So that's how you would use an observable. So what are some of the APIs on the web platform APIs that are going to use observables? Well, we have DOM events and setInterval are obvious cases of 2 interfaces out there that would make sense to be able to use with observables. I think it'd be really nice if this and any future push APIs just all use the same interface, because then we can just think about them all the same way. Now, one of the big benefits, so you don't have to write add event listener or remove event listener. So you subscribe to set timeout slightly differently. Is this really that big a deal? Well, yeah, it is. The reason why we should have one interface for all these types of push APIs and one interface for all these types of async I/O APIs is because of something very powerful: composition. We as developers need to control complexity and build large projects by taking small elements and composing them together. And one of the really powerful things about these types is that they compose. So here I'm going to show you an example of what it might look like. Let's say I want to take a WebSocket, and I want to look for big price spikes in a particular stock. Well, here's an example of how I could use a library like underscore or Lodash. Somebody could write a library like underscore or Lodash. For those of you who aren't familiar, these are a collection of functions used to compose types together. Somebody could easily write a library like Lodash or underscore over our asynchronous iterable interface. And now all of a sudden, we can create, with just a tiny bit of code, a stream that only calls us when a price spikes on a stock. So this is an example of looking for price spikes in the Johnson & Johnson stock and just consuming that data only when we get a price spike. Likewise, you can take observables. I'll just pause for a second to let that. So notice we're using the filter method on arrays. Just like you can use the filter method on arrays, you can use the filter method on asynchronous iterables. And it does the exact same thing. And this scan method, for those of you who aren't familiar with it, it basically behaves like reduce over arrays, except it gives you every intermediary computation. So unlike reduce, scan is just going to sort of keep this stream open and give us every single price spike as it arrives for the lifetime of this WebSocket being open. So you can perform progressively more powerful computations. And for those of you out there who are familiar with functional programming, you know that this is a very powerful and fluent way of writing programs. And so this is one of the big wins out of having a single standard interface for all of these different data sources. Suddenly it becomes really easy for web developers to compose them together. So in addition to composing asynchronous iterables, this is one of my favorite little examples of what it looks like to compose observables. So imagine tomorrow, every single DOM event was suddenly exposed as an observable. So you actually had an object that represented a DOM event, and it had these powerful methods like map and take until and merge all. I can actually write a drag and drop event by composing together a mouse up, a mouse down, and a mouse move event with just a few functions. Now, you don't have to fully understand how this code works, but there are libraries out there already to help you compose together these observables, because observables is just a library, so you don't have to wait for this to come out in JavaScript. You can actually use libraries like RxJS or Bacon.js, which already exist. Think of them as like underscore for events, or Lodash for events, for those of you who are familiar with this. And it's actually a really powerful way of building asynchronous programs. So this is just an example of a tiny little spice of code to write a mouse drag. So I'm going to wrap up here. I actually have more. Honestly, I had a lot of stuff to talk about with ES6, but I only had 30 minutes. But if anybody has any questions about future ES6 features, I may actually have some slides about them. But I'm going to wrap up at this point because I'm pretty much at the 30-minute mark, and just give you my tweet handle there, which you can follow, and I talk about a lot of TC39 stuff. Now, if you want to start using these features, make sure to check out Babel. I'm curious, how many people are using transpilation out there already? Okay, so the good news is you can use some of these features already, and some of you may indeed already be using them. And you can also check out esdiscuss.org, which is where the TC39 goes to engage with the community and talk about these features. If you want to use these features and come back and express your opinion, tell us where those pain points are, that's really valuable to us on the committee. That's one of the reasons why we on the committee love transpilation. It gives you the opportunity to play with these features now, and you know what? If they don't work for you or there's pain points around them, you can let us know before they're fully baked, and then we put them in the language where they're stuck there forever.